Most of what Professor Dmitri Golberg studies can't be seen without an electron microscope. His research involves studying nanomaterials at the atomic level.
You see everything like in real life, but everything downsized to 10 million times. It's about 10,000 times thinner than a human hair.
In the lab here at the QUT Centre for Material Sciences, Professor Golberg synthesises his own nanomaterials. Then, using a technique known as in situ transmission electron microscopy, he manipulates these structures and observes how they change under different conditions such as heat, stress and light. Through tensile strength tests, his team discovered carbon nanotubes are about 100 times stronger than steel.
In theory, it was predicted that all these nanostructures are much stronger, but before these tests were initiated in the microscope, people actually didn't know what's the real properties of these nanomaterials.
Professor Golberg began his research career in Moscow before joining the National Institute for Materials Science in Japan in 1995. There, he became one of the first researchers in the world to study the properties of boron nitride nanotubes.
By serendipity, we found that these tubes exist in nature, because at that time only carbon nanotubes were known to the society.
It turned out boron nitride nanotubes are not only as mechanically strong as carbon, but they also have some other impressive qualities.
Compared to carbon, which can be easily oxidized, boron nitride is very stable to any type of oxidation. So it means for any type of high temperature applications, boron nitride tubes are preferable opposed to carbon.
Today, boron nitride nanotubes may be used to reinforce aluminium, a popular material for aircraft. It's research with a wealth of real-world applications. Professor Golberg has more than 130 patents, primarily in polymers.
Once you put these nanomaterials into the polymer matrix, first of all, you can increase the strength, and second, you can dramatically increase the thermal conductivity.
Beyond the applications, Professor Golberg also has a deep appreciation for the images he sees under the microscope.
When I was a boy, I was very much interested in painting. So I have a choice where to go to become a painter or scientist. And I found that this electron microscopy is a good match between art and science.
In 2016, Professor Golberg received an Australian Laureate Fellowship, prompting him to move to Queensland, where his children were living. He says he's honoured to now also be a Fellow of the Australian Academy of Science.
In Australia, I think people of different nationalities, they can feel Australia home. And I'm still very much happy that at some point of my career we came to Australia.